Welcome back to Respiratory System. So we've finished discussing the gross anatomy of both upper and lower respiratory tracts, and have discussed in detail uh, the terminal ends, no, the bronchioles and alveoli, which are the functional uh, structures in the respiratory tree that are very involved in controlling and maintaining homeostasis respiratory wise, no? As well as mechanics of ventilation, paano gumagalaw yung baga, what makes it move so that you can breathe. Now, we're going to go further into the nitty-gritty of respiratory physiology, and I'm quite sure you will be encountering these concepts and these processes as you go through exercise physiology, and maybe if you do master studies in exercise physiology or kinesiology, or sa inyo na nasa human movement science, you'll definitely encounter this in many reference texts. One of the reasons why I included this kasi during my time as a student in CHK, it was very difficult for me to grasp such concepts kasi parang ano ba to, may math. May mga formula, may mga kung ano-anong symbols, pero hindi naman siya na-explain na maayos. Kasi nga, mahirap din siya i-digest, lalo na kung first time mo siya ma-encounter. So, I will make this your first encounter, and let's try to uh, see the actual human body in action, no? Try to imagine it while I'm discussing the concepts, no? Okay, so let's begin. Okay, so let's define a few terms first to start with. Uh, when you say lung volume, it's an amount of air sa baga that can be measured, no, depending on the function kung inhalation or expiration. It's measured by using this machine called the spirometer, no? Yung nakikita nyo dyan. Actually, may mga mas malalaki pa dyan. If you've ever been in exercise physiology laboratories, mas malaki pa yan. Yan yung nakakabit dun sa mukha ng athlete habang pinapatakbo sa treadmill, no? They're measuring lung volumes using the machine. And then, pag sinabing lung capacity, the capacity is volume of air involved in ventilation that is not measured directly by the machine but can be computed as derived from the volumes measured by the machine. So, bakit marami sila? Kasi, syempre, i-measure mo inhalation, exhalation, tapos, there are other functions in the lungs as well, in the lung space. Okay, so let's go through them one by one. Let's start with the most commonly used, which is tidal volume. When you use tidal volume, that's during normal ventilation or quiet breathing. Yung hinga na hindi mo napapansin. So that's total of inhaled and exhaled air. It's also the smallest volume kasi nga minimal lang yung need ng katawan eh. So nasa 500 ml of air flow in and out na yan. Total yan. Okay, next. If you say you've already inhaled during quiet breathing and then you napahikab ka, no? So, meron pang capacity or meron pang space dun sa baga to be filled maximally. And that is consumed when you use the inspiratory reserve volume. No? 6 times the volume of tidal volume. So, definitely yung dalawang baga mo, malaking-malaki yung amount of air na kaya nilang hawakan. Next, the opposite is your expiratory reserve volume. Normal breathing. After you exhale during normal breathing, you forcefully exhale some more. So, yun yung expiratory reserve. No? Tandaan, yung reserve volumes natin, hindi kasama doon yung tidal volume. If you will look at the graph here in the bottom, no? Hiwalay sila, hindi sila nakasum doon sa tidal volume. Kaya sila reserve. No? Okay, next. Residual volume. Si residual volume is the amount of air that always remains, no? in the air spaces even if you exhale maximally. So, ibig sabihin, yung mga contest na pahabaan ng pag-exhale, no? Or yung sasabihin mo yung pangalan ng birthday celebrant tapos hanggang maubos yung hininga mo. Hindi totoo na mauubos yung hininga mo kasi there's always residual volume. Kasi you have to have some reserve of oxygen and carbon dioxide for continuous gas exchange. Kasi kahit huminga ka ng buo na maximally, no, yung blood mo, umaagos pa rin ng umaagos sa baga mo. So, there has to be some gas exchange there. Kaya si residual volume, nandyan. No? It's also one of the necessary volumes pagdating sa yung mga deep sea diving na walang equipment, no? After they've already used up the expiratory reserve volume, kasi paunti-unti, di ba, mag-exhale. There will always be some amount of air left, and that's your residual volume. Now, let's go for functional residual capacity. So, ito na yung mga kino-compute. Sa mga machines na makikita nyo sa exercise physiology lab, yung mga capacities actually mean nakaka-compute na sila on their own kasi may algorithm sa computer ng machine. Pero for the purpose of this class, aralin nyo kung paano mag-compute mamaya. Okay, so let's go to functional residual capacity. So this amount of air is the sum of your expiratory reserve volume and your residual volume. No? It's determined by the balance of negative pressure sa thoracic cage. So, negative pressure pagka yung pull because of the pleural cavity, di ba? And the positive pressure. So, meron kang negative pressure pa-expand, positive pressure pushing air out. So, yung interaction ng forces ng pressures na yon is your functional residual capacity. Okay. Tapos, has more oxygen than what you are able to take in per breath. So, extra amount of gas for gas exchange, even if you maximally inhaled and exhaled. Okay. Sige. Next is your inspiratory capacity. Inspiratory capacity is a sum of your tidal volume and your inspiratory reserve volume. Tapos, vital capacity, yan yung gamit na gamit kapag nag-training kayo. Kasi it's the combination of your inspiratory reserve, tidal volume, tsaka expiratory reserve. Say, when you're doing forceful breathing kasi, lalo na kung pagod na pagod kayo sa exercise, diba? Yung initiation ng breath nyo, whether inhalation or exhalation, yung first 500 ml niyan, tidal volume na. Pero dahil gumagamit na kayo ng accessory muscles, no? Sternocleidomastoids, scalenes, tapos yung intercostals, tsaka yung abdominal muscles, no? Na further pa nagagamit parehong IRV tsaka ERV. Kaya ang ginagamit nyo dyan in total is your vital capacity. Okay. And then last is the total lung capacity. So kung na-measure mo na lahat ng volumes, makukompute mo kung ano yung total capacity ng set of lungs, no? Yung pair of lungs ng tao na yun. Tapos divide mo by 2 to estimate per lung. So ganoon lang siya. In real life, unless you go to exercise physiology at use it in a lab, you'll probably not encounter this again. Pero I know some of you who are probably thinking of going there. So this will be very useful. Okay, tuturuan ko kayo ng shortcut. Di ba, yung mga volumes, usually given yan. Yung capacity, kino-compute pa yan. So let's learn how to compute. Merong shortcut. Kasi di ba kanina ang daming palang plus plus man. So, ganito ang ano dyan. Before you encounter a problem regarding lung volumes and capacities, isulat nyo na kagad to sa notebook or sa papel, no? 1, 2, baliktad. Reverse natin. 4, 3, 2, 1. Okay. So, yung 4 natin, tatandaan lang yung 4 iter. I, T, E, R. So, si I, V. Tidal volume, ERV, residual volume. Sa lahat ng volumes, no? Yun yung first 4. Okay. The first 3, doon sa tatlo, this is going to be your first 3, VC, or forced vital capacity. Vital capacity, forced vital capacity, same lang. The first 2, IRV and TV, no? This is your IC. And then ERV and RV, no? This is your FRC. And then C1 gives you TLC. The 1 gives you TLC. So, medyo mas madali siyang tandaan. If may mga formula kayong ma-encounter, i-plot mo lang yan, tapos plus, plus, minus, minus lang yan. Para at least alam mo kung ano yung kung paano mo siya hahanapin. Mas madali. So, you write that down sa lecture guide with the box provided, the space there, para hindi nyo makalimutan. Okay? Sige. So, let's go to the next. And yung medyo mas mahirap. Okay. Sorry, I almost forgot pala, no? Yung sa other item after nung box na may space for writing the iter method. That's the anatomic dead space. Makikita nyo rin yan in a lot of text. So, si anatomic dead space, never siyang na-exhale, never siyang nadadagdagan ng inhalation. Lagi lang siyang nasa air spaces. Plus, it does not participate in gas exchange. So, iba siya sa residual volume and functional residual capacity. Yun yung defining term niya, not participating in gas exchange. So, nandun lang siya. Actually, paano mo i-make sense yan kung nasan si anatomic dead space? Saan ba nangyayari ang gas exchange? Dito sa alveoli natin. So, any amount of air that doesn't leave the respiratory tree, trachea, bronchi, bronchioles, no? Maliliit na tubo lang sila eh. So, yung total volume na yun is your anatomic dead space. In the areas in the respiratory tree that have less cartilage, particularly your bronchioles, no? Mas nandun sila nagre-reside kasi that anatomic dead space keeps those tubes open. No? Kasi wala nga silang reinforcing structures, wala silang cartilage. Diba? Okay, so now that we've completed that, let's go to how gas exchange occurs in the alveoli. In grade school, sasabihin lang sa inyo, in the alveolus, it's where oxygen goes to the blood and carbon dioxide exits the blood to be exhaled. That's grade school. Let's go to college na. So, your alveoli, they call the structure, no? Which is the respiratory membrane. Composed of your type 1 pneumocytes, yung may structural function na cell, and the type 2 pneumocytes which produces surfactant para hindi mag-collapse yung alveolus kung mabasa ng tubig. Okay. The respiratory membrane is yun yung wall ng alveolus. And then, so, ayan, nasa image na natin siya. So, this part, yan, this is the respiratory membrane. Okay? And then, this is the alveolar membrane. And then, dahil sa pagdidikit ng endothelium ng capillary. Pag sinabing endothelium of the capillary or any blood vessel, yun yung inner lining niya. Pero in the case of a capillary kasi, wala na siyang outer lining, wala siyang outer layers. One layer lang siya. So, yung pag pinagtabi mo, yung endothelium ng capillary at ng alveolar membrane, that is what we call the respiratory membrane. It looks like a membrane on its own na manipis kasi nga, sa sobrang nipis ng dalawang components, mukha na siyang isa. No? Pero may space pa din between that. What we call the interstitial space, which has mostly water and some dissolved solutes. Okay. So, the blood-air barrier or the respiratory membrane, no? is where gas exchange occurs. It's the interface between blood and air. Tapos may harang syempre kasi dapat gases lang ang pwedeng pumasok. It's very thin, no? Ang measurement ng thickness niya is 0.2 to 0.6 micrometers. To give you an idea how thin, the coronavirus virion, yung isang viral particle, is 0.125 micrometer in size. So, halos yung respiratory membrane nyo, yung nipis niya is almost not seen by the naked eye. No? Kasi, ano ba ang dadaan dyan? Gas molecules which are relatively small. No? So, for maximum diffusion, dapat ganun siya. Okay. Since gas exchange is an issue of function, no? Kasi pag poor ang gas exchange, you're going to get sick, or inadequate oxygenation, you're dead. No? So, ano ba yung mga bagay na nakaka-apekto doon? At the level of the blood-air barrier, you have the thickness of the membrane. So, kung makapal si membrane, mas mahirap tumagos si gas. Pag mas manipis or adequately manipis like the normal, madaling makakapasok si gas in and out. Next is surface area. You've already encountered this matter before, and I'm quite sure you're familiar about it now. Surface area is always the thing in living systems kasi efficiency. Next is pressure difference. So, mamaya i-discuss natin yan further. And then the diffusion coefficient of gas. This is something that you just have to remember. This is a physics matter already. And you don't have to try to delve into it. Tandaan nyo lang, the diffusion coefficient of gas. Different gases have different diffusion coefficients. Pag sabi kasing coefficient, fixed value siya. So, usually, ano ba? Hindi, wag na. Okay, basta, ibang diffusion coefficient ng oxygen, iba kay carbon dioxide. Parang ganun. Okay. Sige, let's talk about how gases can go through that membrane. There are two laws. Actually, there are several, pero I will only have you learn about two that are significant and rather easy to I understand. The first law is Dalton's law of partial pressure. Pag sinabing partial pressure, it's the pressure contributed by one gas in a mixture of gases. Okay, science na naman. Sige, ganito. Look, feel the air around you. No? That air, pag sinabing air, it's a mix of different gas molecules. No? Or gas atoms. No? Sa atmosphere natin, no? Majority of the gas around us is nitrogen. No? And then 21% or 22% is composed of oxygen. So oxygen, ang parte niya 20% lang. The rest is carbon dioxide plus other dissolved gases. Kasi hindi lang yun tatlo. May carbon monoxide, noble gases like argon, some helium, ganyan, neon. Okay. So yun, lahat, yung total pressure ng atmosphere natin at sea level is computed at 760 millimeters mercury. Millimeters mercury is the unit of measure para sa pressure. Kung gumagamit kayo kung may sasakyan kayo, tapos marunong kayong magbutingting or mag-check man lang ng tire pressure nyo, makikita nyo siguro PSI, no? Pero may equivalent yon in millimeter mercury. Yun ang standard of measure. Millimeter mercury. Tapos, bali yun. Sa total na 760 na yon, na ine-exert na pressure ng hangin sa paligid nyo, 20% of that comes from the pressure exerted by oxygen. So, para malaman natin kung gaano kalakas tumulak ang oxygen dun sa respiratory membrane, kailangan alam natin yung partial pressure niya. Same goes with carbon dioxide. No? Kasi, magmamatter ngayon mag-a-apply ngayon yung pangalawang law, no? Which is Fick's law of diffusion by Adolf Fick. No? So, with Fick's law of diffusion, an area with a higher pressure yung particles na yun causing that high pressure tend to move down to an area of low pressure of the same particles, no? So parang ano lang siya, demand and supply siya. Kung saan masikip, no? Kung saan maraming supply, ang tendency is to move down to areas na kulang. At least that's for the human body. So, say for example, uh, if you will look at the table sa inyong lecture guide, makikita nyo dyan yung list of the partial pressures of oxygen and carbon dioxide and nitrogen din in different areas where air is present. No? So, meron kang trachea, alveoli, arterial blood, mixed venous blood. And then, na-mention ko na yung partial pressure ng oxygen tsaka carbon dioxide sa atmosphere. Okay? So, ang mangyayari niyan, applying the two laws, pag dumating tayo sa alveolus, if you look at your diagram, you will see here in the blood vessel that the oxygenated blood from the pulmonary artery, meaning ito, itong dugo na galing sa puso na naubusan na ng oxygen, goes into the alveolus, the capillary adjacent to the alveolus. And then, dahil kulang siya sa oxygen, no, mababa yung partial pressure ng oxygen dyan sa area na yan. Dito, sa purple, no? Sa blue. No? So, tignan, if you look at the table, no, you'll see that mixed venous blood, yan yung nasa pulmonary artery, has a partial pressure of oxygen at 40. No? Tapos, to compare it with the partial pressure of oxygen inside the alveolus, yung hangin na in-inhale nyo, the partial pressure is 104. So, anong mas malaki? 104 or 40? Easy enough, 104. No? So, applying Fick's law of diffusion na kung saan mas madami, pupunta sa mas konti. So, mangyayari, by matter of physics lang, di mo kailangan ng kung anong contraption, oxygen will readily go to the mixed venous blood in the capillary. Kasi, yun yung mas mababang area na, mas mababang partial pressure na area. Whereas, di ba? Kaya mixed venous blood, kasi hindi lang oxygen lang nandyan. Blood coming from the body that was used for gas exchange sa katawan, pagka na-pump siya pabalik sa baga, mataas ang pressure ng carbon dioxide. That carbon dioxide is accumulated from working muscles, mga na-damage na tissues, na kinuha lahat, pinick up ng dugo na dadaan sa veins. So the partial pressure of carbon dioxide there is 46. Whereas the partial pressure of carbon dioxide sa atmospheric air that you just inhaled is 40. So maliit pero may difference pa din. By law of diffusion, kung saan mas madami, pupunta sa mas konti. So carbon dioxide will have a tendency to go into the alveolus. Okay? So that's happening at this point, no? Right here. Okay. So, ngayon, nakaagos na, para patapos na, makakalabas na si oxygenated blood ngayon doon sa pulmonary vein, pabalik sa puso para i-redistribute sa katawan. And then, the cycle just continues. Okay? So, nagigets kung paano siya gumagana. No? Tandaan yung dalawang laws, tandaan yung mga factors affecting gas exchange. Kasi, paano kung yung laws of physics present yan every time. No? So, yung mga bagay na pwedeng mabago will be yung membrane. Paano kung maga yung baga? No? Like sa mga taong may infection sa baga. So, hirap silang huminga kasi pangit ang gas exchange. No? Pagka pangit ang surface area ng membrane, meaning kokonti, nabawasan yung alveoli. No? Mamaya, makikita niyo yung eksena na yan. And then, yung pressure difference. Paano kung mahina ang oxygen pressure sa atmosphere? As in the case of altitude, high altitude exposure. Sa matataas na area, sasabihin sa'yo, manipis ang hangin dito. Hindi lang yung buong hangin. Particularly oxygen is low there. Yung partial pressure ng hangin natin mas mahina. So, with a body coming from sea level, mababawasan ngayon yung diferensya. Pag mababa ang gradient, mas bawas ang diffusion. Naintindihan? Okay. So, let's move now. No? Nangyari na yung gas exchange. Pag-usapan natin paano siya ikakalat ng katawan para magamit. Alright, so here we are with this very famous protein, no? Si hemoglobin. No? Ah, si hemoglobin, no? Isa siyang what we call a quaternary structure protein. Pag sinabing quaternary, meaning yan na yung pinaka-complex. Kung mapapansin nyo, hindi ang drawing ni hemoglobin mo, hindi yung stick na may ganyan-ganyan, no? Hindi siya basic na molecule lang. Maraming ganito sa bawat kurba nito, tapos naka-twist yan sa loob. Ayan, nakaganyan yan. Tapos some of them are folded, no? Naalala yung sa discussion natin ng cell, no? Na modify ang peptides mo to be twisted, folded. Kaya nagkakaroon ka ng complex proteins like hemoglobin. Si hemoglobin is unique in such a way that it holds within each unit. So itong purple, isa yan. Itong isang blue, isa yan. And then the other blue, isa yan. And then the other purple, isa yan. So you have 4 units of heme per hemoglobin molecule. Okay. So yung kada unit ng heme na yon, merong taglay na ferrous ion, no? So Fe2+. So si Fe2+, kailangan siya ni hemoglobin para makatrap ng oxygen from blood or from the lungs, depende kung saan. No? So, doon siya na-trap. So, per hemoglobin, 4 na oxygen ang kaya niyang i-trap. And when oxygen binds to hemoglobin, it changes its shape, no? Pagka kasi walang nakabind kay hemoglobin, para siyang ganyan. Nakamuka, relaxed yung protein. Pag may kumabit na oxygen, magti-twist siya to lock the oxygen in place. Kasi, wala pa siya sa patutunguhan niya. Galing, no? So, nag-change yung structure niya. And that hemoglobin with oxygen molecules is your oxyhemoglobin. Tandaan, hindi lahat ng i-inhale nyo na oxygen didikit kay hemoglobin. Some can just simply float around in plasma, yung sa water component ng dugo. Mga 2%, no? Okay. Now, si hemoglobin, hindi siya limited na dumikit lang or kumabit lang sa oxygen. It can also carry other gases, particularly carbon dioxide. Pag carbon dioxide ang kasama niya, it's called carbaminohemoglobin. Tapos, there's another gas that's actually poisonous called carbon monoxide. Maraming ganyan sa usok ng tambucho. That can also bind to hemoglobin. So, yun. Let's talk about how hemoglobin functions to move gas around as well as to deliver gas and to receive gas. No? Kasi kailangan, hindi lang naman dikit lang tapos ikot lang siya ng ikot. Dapat kaya niya ipasa. So, okay. So, correction pala sa lecture guide, I just noticed now. Yung concept of peripheral gas exchange. Maaga siyang nakalagay. No? So, dapat ano muna siya. Sa dulo siya, after nung some terms to define. Okay. Kasi, yan yung mangyayari pagka natapos na yung alveolar gas exchange. Sige. So, balik muna tayo kay hemoglobin. So, your hemoglobin has a capacity to be flexible. Ang pagdikit ng oxygen sa kanya or carbon dioxide, hindi yan permanent. Kasi dapat kayang i-release. Kayang hawakan, kayang i-release. No? So, reversible and temporary ang kanyang binding to the gases. Okay. Tapos, yung amount of saturation ni hemoglobin, nagbabago yan. Pagka tumataas ang partial pressure ng oxygen, kung saan man siya, mas tumataas ang saturation ng hemoglobin. Pag sinabing saturation, marami kang hemoglobin within a particular volume of blood. No? So tama lang, directly related. No? Mas maraming oxygen sa paligid, mas masasaturate ang hemoglobin natin. And nagbabago siya depending on the area of the body it is currently in. Huh? So let's talk about what affects the efficiency of hemoglobin, particularly what affects the tendency of hemoglobin to either hold on to oxygen or to release oxygen. Okay. This is determined by this graph below, no? So medyo mahirap lang intindihan at first. This is what we call the oxygen hemoglobin dissociation curve. Dissociation meaning yung pag-release, no? Kasi mas gusto natin kaya niyang humawak saglit pero magbigay ng oxygen. Okay? So kaya yun yung priority term. Okay. Now, yung sinasabi kong kaya ni hemoglobin kumapit tsaka magbitaw ng oxygen is determined by several factors. And this is intuitive actually. When hemoglobin can easily hold on to and keep within yung oxygen, it's usually in areas kung saan mababa ang carbon dioxide, mataas ang pH, may presence of substance called 2,3-BPG. In the case of fetuses, yung mga baby na nasa loob pa ni nanay, tsaka pag malamig ang core temperature, no? So, let's discuss them na lang as a whole, no? Kapag mababa ang carbon dioxide sa isang area, ibig sabihin, hindi highly metabolic yun. Ano ba ang carbon dioxide? Waste product siya. So, if you have little carbon dioxide in a particular area, ibig sabihin, hindi masyadong nagtatrabaho yung area na yun. Therefore, mababa yung demand for oxygen. Kaya, instead of bitawan na lang ni hemoglobin, tatabi muna niya hanggang dumating siya sa area na nangangailangan. Increased pH or alkalosis or actually normal pH. Pag mas mataas ang pH, yun din, senyales yun na hindi masyadong busy yung area na yun. No? So, tabi na lang, bigay sa mas nangangailangan. In babies, in fetuses, no? Sila kasi wala silang baga. Yung dugo nila, nakadugtong lang kay nanay. So, para masigurado na adequate ang oxygen na umaagos sa dugo nila, yung hemoglobin nila is not the same as ours. Yung hemoglobin nila mas makapit sa oxygen. Para every time na dadaan dun sa placenta, kung saan nandun yung dugo ni nanay, mas malakas siyang kumain ng oxygen. Kaya nagpe-ferrous sulfate kila mami kasi nag-aagawan sila ng oxygen. No? Mas malakas mang-agaw yung oxygen yung dugo ni baby. And then decreased temperature. So another sign of low metabolic activity. Okay? So, medyo may sense, no? Kasi tignan mo, yung dugo natin, it follows a unidirectional flow. So, kung ano yung pinakamalapit sa puso, yun yung unang bibigyan ng oxygen. Kaya lang, kung ang mas busy na parte ng katawan natin ay kamay, for example, hindi ka naman hinahapo or hinihingal, pero you're busy writing, you're busy typing, you're busy playing with your phone, no? So, distal siya, malayo siya na area ng katawan. Kung wala tayo nito, na hemoglobin will just easily give off oxygen and take oxygen, kakadaan pa lang lampas ng puso, mangangalahati na yung oxygen na meron yung dugo. Paano na sa dulo? Wala na. So, nakikita nyo, hemoglobin has its own automatic mechanisms governed by chemistry and physics to make sure that oxygen is brought to where it is needed the most. Galing, di ba? Sana ganyan sa lahat, no? Okay. Next, okay. So, yung first pala na yon, yung first set of factors na yon, causes sa graph what we call a shift to the left. So, pag sinabing shift to the left, no? Ito siya. Ito yung normal curve, no? Pupunta siya dito. May tendency siya na at a given kahit mas maliit yung oxygen partial pressure, mas madaling umangat yung hemoglobin saturation kasi mas makapit nga siya sa oxygen. Okay, next, the opposite naman. So, when the curve shifts to the right or when hemoglobin easily lets go of oxygen. No? So, in an area of increased carbon dioxide, decreased pH or acidotic na area, or during exercise and increased temperature, so lahat yan, events where there is high cellular metabolism. No? So, pag very active ang cells, mataas ang rate of metabolic processes occurring, mas kailangan niya ng oxygen. Kaya intuitively, mas bibigyan ni hemoglobin ng oxygen yung areas na merong ganyan. Tapos, tandaan nyo na lang yung 2,3 BPG, decreased to 2,3 BPG. This molecule is just here to complete the list, pero hindi natin siya kailangan aralin. Medical na yan. Okay? So, pang-kompleto lang ng list. Merong mas madaling way para kabisaduhin ito. Kasi parang ang dami-dami, ililista ko pa. No? Tandaan nyo, yung 4 na factors dun sa left and sa right, pareho lang. Nag-iiba lang ng direction, kung increase or decrease. So, tandaan mo na lang yung sa right. No? Sa right, increased carbon dioxide, yan yung C. Decreased pH, which is interpreted as acidosis. So, that's A, acidosis. And then, decrease 2,3 BPG, exercise, which is very familiar to you, and increase in temperature. The mnemonic there, or the way to memorize it easy, is with hemoglobin, kapag meron kang kabit, do the right thing, so the curve shifts to the right, let go of oxygen. Pero in real life, pwede rin to, di ba? Kapag may kabit, you do the right thing, you let go of, ikaw na bahalang pumili. Okay, sige. Some terms to define kasi these terms will be encountered frequently and you will probably encounter it at some point in your in your advanced subjects. Pag sinabing hypoxemia, hypo meaning low, oxemia meaning oxygen in the blood. So it's low oxygen saturation sa dugo. No? Pagka mababa ang oxygen sa dugo, it will always cause hypoxia. Hypoxia is yung oxygen, low oxygen sa mga tissues, sa muscles, so kung other organs apart from the blood. So kung ang dugo, yung supply chain mo, mababa ang oxygen, definitely bababa yung oxygen sa other tissues na nangangailangan. In the opposite though, hypoxia, pag sabi hypoxia, low oxygen saturation sa other tissues, hypoxia is not always caused by hypoxemia. Kasi yung dugo, no, pwedeng okay ang oxygen na laman, kaya lang yung tubo, kung saan dumadaan yung dugo, nabarahan. So, mawawala ng supply, yung tissue, mag-hypoxia siya, pero yung dugo mo, may oxygen pa din. No? So, magkaiba yung dalawa. Okay, next, acidosis. Tandaan po, hindi po acidic. Wala pong acidic na katawan. Okay? Acidosis means there is decreased pH. Ang pH po is ion concentration, specifically hydrogen ions. No? Pag sinabing decreased pH, ibig sabihin mas maraming hydrogen ions dun sa solution na meron ka. Hydrogen ions are usually given off lalo na kapag may mga catabolic processes ka and sobrang dami nila. So, merong excess. Kaya nagkakaroon ng decreased pH or low pH. Bakit hindi na lang increased pH is increased H+? Tanungin niyo po yung nag-compute. Paano yung nag-compute ng pH as a function. It's a logarithmic function. Kaya siya ganyan. So, tandaan, wag malilito, ha? Decreased pH is caused by, pH is low because there is an increase in hydrogen ions. Okay? Next, on the opposite is alkalosis. Hindi po alkalinic. Wala pong alkalinic na katawan. Okay? Huwag kayong maniwala dun sa sinasabi-sabi ng mga nagbebenta ng alkaline water. Ha? Increased pH pag sinabing alkalosis, which means there is lower hydrogen ion concentrations. The way our body makes sure, kasi highly metabolic lalo na pag exercise ka. Acidosis is not okay, no? Lalo na kung sobra. Our body will naturally produce bicarbonate para ma-maintain yung alkalosis natin. And usually, if you have an increased pH, it's just because you have a lot of bicarbonate in the body. Galing sa kidneys mo yan. Okay? Or if you're able to exhale carbon dioxide, you gradually shift back to alkalosis. No? Okay. Sige. Next. Natapos na tayo sa physics, chemistry. Balik na naman tayo ulit sa, hindi, joke lang, wala na masyado dito. This is just a measure of performance na. Okay, let's talk about ventilation and perfusion. This one will come up in your exercise physiology, particularly pag nasa respiratory functions kayo ng athletes, no? Respiratory and circulatory functions. Okay, tandaan. The function of the lungs with getting oxygen and releasing carbon dioxide is work hand in hand closely with the function of your cardiovascular system, particularly how blood flows and if yung function ng red blood cells nyo. Kasi if you have one without the other, you're still dead. No? So you gotta have a good function of both. And ventilation comes from the function of the lungs to mechanically bring in gas or bring in air and push out air. Perfusion is a function of your cardiovascular system. Perfuse meaning yung capacity to move blood into tissues in the body. No? So yan sila. Yung ventilation is signified by the letter V. Perfusion is signified by the letter Q. Let's not ask why na. Okay na yan. Given na lang siya. Okay. There is a measure of function that we call as VQ ratio. Itong ratio na to, wala po itong value. Hindi to yung may ml, hindi po ito may milligrams. Okay? A ratio is just a ratio. It's just a numeric quantity that tells you kung nagtatapat ba yung rate of ventilation and the rate of perfusion. Okay. The value of your ratio is more important than measuring just ventilation or just perfusion. If you will recall, na-discuss ko dun sa lung volumes topic natin, merong tinatawag na spirometry, which measures the amount of air going in and out. And that is a measure of your ventilation. Sa perfusion side, may mga devices that can actually measure blood flow, no? And estimate the amount of blood flowing into the lungs. No? So if you get data from the two tests or from the two machines, you can actually compute for the VQ ratio. No? A normal person, untrained, nakapahinga, has a VQ ratio of 0.8. Diba ang ratio natin, numerator over denominator. So, pag ang numerator mo mas mataas kesa sa denominator mo, no? A tendency of the value is higher, no? Pero in this case kasi 0.8 lang, di ba? If you have a ratio of 1, ibig sabihin 1:1 sila. So ito, less than to 0.8 less than 1 to. So ibig sabihin, yung ventilation natin at rest, mas mababa compared to the amount of blood flowing through the lungs, no? And yan, kaya siya 0.8, kaya hindi siya perfect 1. Okay. Now, let's go to how it changes. Ano yung discrepancies sa kanya? Look at the diagram with the table sa lecture guide sa page 4, first upper left-hand side. No? So, that represents one lung. And we have what we call lung zones. No? Yung lung zones na yan are defined as such kasi depende dun sa amount of air and blood flowing through each zone. So we have zone 1, zone 2, zone 3. Imaginary lang yan. Hindi yan part of the anatomy of the lung. So please, walang magsasagot ng zone 1 to define the apex. No? This is just for the purpose of VQ ratio explanation alone. Okay. Sa area of the apex, if you will look at this diagram sa baba, no? Sa taas kasi, dahil mas mataas siya, and your gas, no? Yung hangin, made of particles pa din yan. So, may timbang yung hangin na yan. Because the apex is located at a narrower portion, so mas maliit yung area niya, at the same time, it's at the highest portion. If you're standing up and you take a deep breath, the tendency of the gas is to move more downwards because of gravity, tsaka yung orientation ng mga bronchi mo. So si apex, medyo bitin yung hangin na umakyat sa kanya. Kaya siya yung area na medyo mas mababa ang flow of air or ventilation. At the same time, if you're standing, blood flow is also affected. Blood is fluid plus with solid components yung mga cells mo. So lahat yun, meron ding timbang. If you're upright, no? Kahit marami ka rin blood vessels sa taas, actually, yung blood vessels sa taas ng baga, konti din eh. Kasi habang tumutubo sila, parang ugat lang din yan parang halaman lang din yan eh. Gravity will affect yung pagtubo ng blood vessels dun sa isang area. So sa baga, less din yung blood vessels dyan. At mas mabagal dumaloy ang dugo dyan kasi gravity, matter of gravity lang siya. So perfusion there is lowest. Huh? On the opposite, sa base, no? Diyan yung mas mataas ang ventilation, diyan din relatively mas mataas ang perfusion to a point na mas mataas yung rate of perfusion significantly over the rate of ventilation. Kasi sa perfusion, pwede pa siya magbago eh. There are blood vessels that can form newly formed blood vessels. Sa respiratory tree natin, when we get to adults, usually fixed na yan. Wala kang bagong bronchioles. No? Unlike your capillaries, na pwede silang mas dumami. Kaya makikita nyo sa table, blood flow in zone 3 is highest, pero yung ventilation mo higher. No? So yung value nila medyo mas mataas. Kaya mangyayari, pagdating sa VQ ratio natin, ito medyo nakakalito. Makikita nyo, VQ here is highest. No? Kasi ventilation, isang factor lang eh. Airflow lang. Hindi mo na mababago yung bronchioles. Eh. Pero pagdating sa perfusion sa apex, dalawang values yan eh. Yung gravity affecting the flow of the blood and yung gravity that slows down the growth of capillaries dun sa taas. So, mas mataas yung, mas malaki yung difference. So, meaning, if you will have an actual value of V, it's significantly higher than Q in that area alone. Ha? Hindi pa to yung relative sa ibang areas. Okay? Kaya pag nag-compute ka ng VQ ratio dyan, mataas ang VQ ratio, 3.0. Pagka mas mataas ang VQ ratio, hindi siya mas okay. Whether negative or positive. Kasi, mas palayo ka ng palayo sa ratio of 1, mas malaki yung diferensya sa pagpasok ng hangin tsaka pagpasok ng dugo. Pag hindi kasi sila magkatapat, ibig sabihin, if you have less blood flowing, kahit gaano karaming hangin pumasok dito, yung dami ng oxygen lang napapasok is dependent on this, yung blood na onte. Merong limiting factor. Kaya dyan yung pinaka inefficient. Kasi masyadong malaki yung VQ ratio from the normal. No? Sa base natin, lowest na VQ ratio which is 0.6. Si zone 2, yan yung 0.8 mo kasi relatively match sila dyan. Kasi nasa gitna lang. Ang problema naman kasi sa zone 3, because of gravity again, the two factors in perfusion, yung growth ng capillaries plus blood flow is exponentially increased. So, mangyayari, yung V mo is, compared to Q, significantly less. Pero hindi ganun kalaki yung discrepancy. No? Kasi pareho silang nasa baba eh. Medyo mas mataas din naman yung airflow dyan because of gravity. Kaya lang, mas exponential yung increase kay perfusion. So, nangyayari, yung ratio nila is 0.6. A little close to normal. pero less efficient pa din. Kasi nga, rumaraga sa yung dugo, yung daloy ng hangin, kahit malakas din, pero dahil mas mabilis yung daloy ng dugo, some of the blood cells do not have enough time to pick up whatever gas is coming in because it flows faster. Nagigets ba? It's confusing. So if it confuses you, message me immediately or post the question or any specific question sa group chat para ma-clarify natin. Kasi ina-expect ko hindi nyo to magigets agad. Pero once na magets nyo to, dadali ang buhay nyo when it comes to exercise physiology. Promise yan. Okay. Sige. Let's talk about 1. No? A VQ ratio of 1. Is it possible to achieve it? Yes. No? That's where you are now in CHK. When you exercise, mas forceful ang paghinga, mas mabilis ang paghinga. At the same time, as a response of your endocrine system during exercise, bumibilis din ang tibok ng puso at daloy ng dugo. Kasi di ba may vasodilation tayo, plus bronchodilation, no? Tsaka increased heart rate. No? So, in exercise, a ratio of 1, which is the best ratio, meaning kada daan ng red blood cell, puno siya ng oxygen. So, yun yung pinaka-efficient. Lahat puno. Kada agos. No? Meaning, kada agos din, lahat ng carbon dioxide, eject. No? Walang naiiwan, walang natitira. It's achieved in exercise. Kasi nga, parehong tumataas ng sabay to a point na nag-aabot sila na pantay. Okay. On the opposite end, there are problems that can worsen the ratio, meaning mas magkaroon ng malaking discrepancy or difference sa ventilation and perfusion. Nadadaanan natin. Okay. Sige. I understand that some CHK students are smokers. I've been to CHK. I never smoke, pero hindi ko rin kasi mag-gets yung kung bakit masarap siya. For some people. Pero I know athletes, I know a lot of athletes who smoke and they say, oh, I'm fine, it's okay. Nag-training naman ako eh. Hindi naman ako nakakaramdam ng sintomas eh. Hindi talaga. Kasi there are effects of training. No? Pero, say for example, you're a non-athlete and you're smoking now, the effects will not happen agad. Pero it can be progressive. No? To a point that it can lead to a disease or a group of diseases called COPD or chronic obstructive pulmonary disease. So, COPD, grupo yan ng mga sakit. Pero usually, ang meron ka will be 2 diseases. One is emphysema, the other is chronic bronchitis. Pagdating sa chronic bronchitis, sumisikip yung bronchioles, no? Yung mga small na muscular parts of the respiratory tree, magta-tighten sila and masyadong maraming mucus. Kasi nga, yung yosi, hindi naman yan natural sa baga mo eh. Pollutants yan eh. Anything that's irritating to the bronchioles, di ba na-mention ko, will cause a constriction reflex. Pero in the case of smoking, if you do it daily, that constriction reflex becomes no longer a reflex. Permanently or chronically, magiging masikip tsaka mucus-filled ang bronchioles mo. At the same time, pwede rin naman mangyari because of the heat, the tar, the other toxic substances sa smoke, na umaabot yan sa level of the alveoli, can cause the alveoli to pop, di ba? Maliliit na cells sila, no? Maliliit na acini or alveoli, no? Manipis lang yun, di ba? One cell layer lang. So if you have an irritating substance, the tendency of that cell layer is to just disintegrate. Tapos, kakapal na lang siya, no? As a way to, as a defensive mechanism. Sa katawan kasi ng tao, if you incur damage on one area of the body, the tendency of that area is to grow thicker, to grow mas makapal, you know, to resist the damage na pwede pang dumating ulit. So, nangyari, yung baga nagiging ganyan din. Anong problem dito? Ano yung factors affecting gas exchange, no? Diba? One of that is the thickness of the membrane. So, si emphysema, mas makapal na yung membrane. And surface area. Mas malaki surface area, better efficiency. Onti ang surface area, less efficiency. In this case, si emphysema, nawala na yung mga convolutions kasi naging isang malaking lobo na lang siya. So, exponentially bawas ang surface area. So, gas exchange alone dito sa area na to, sobrang baba, no? Kasi exponential yung effect dahil there are two factors reduced. So, yung dalawa na yan, magkaibang sakit yan, pero usually in smokers, sabay sila nangyayari, and that's what consists your COPD, bronchitis and emphysema, which is a direct effect of smoking. Now, there's another problem. Actually, guys, smoking does not only affect the lungs because there are substances in the lungs that can easily cross the blood-air barrier and go to the blood vessels. And those substances are highly toxic, highly volatile, so they can cause tissue damage. One of the parts of the body that is easily affected by cigarette smoke are the small vessels, no, your arterioles, no, venules. Pag naapektuhan sila, nangyayari parang sa bronchitis, kumakapal, naiirita kasi. So, nadadamage sila, kakapal, tapos liliit yung kalibre. So, mangyayari, apart from a ventilation problem lang na meron ka, you also have a perfusion problem. Now, the effect in the lungs are usually what come first before the effect in the blood vessels. So, on the onset pa lang, pag matagal ka na nag-yosi, magkakaroon ka na ng malaking discrepancy or difference between the ventilation and perfusion. So, ano mangyayari? Yung VQ ratio mo, dahil mas maliit si ventilation, si perfusion, di pa gaanong affected, no? The VQ ratio becomes significantly smaller and farther away from the perfect ratio of 1. No? So, yun. Smoking has, quiet siya eh. Actually, hindi. Kasi ububuhin ka na sa simula eh. Pero, it's addicting. Force of habit, peer pressure, no? Kasi culturally acceptable ka sa peers mo if you smoke. Pero the problem is, are your peers still there when you develop such a disease, di ba? Hindi. Hindi sila magbibigay ng pera sa'yo. Wala silang pangyosi eh. Tsaka sila may sakit na rin. Okay. Thing is, with smoking, ang problema sa COPD, hindi siya, it cannot totally be reversed, lalo na kung lasting na yung damages niya. Meron kasi siyang counterpart na sakit. Si asthma, parang ganun din, may bronchoconstriction siya because of the inflammation. However, hindi kasi chronic yung effect nun. So, pwede mo siyang, pag ginamot siya, yung mga nag-inhaler, pwede mo siyang pabalikin. No? So, reversible siya. It can be fully reversed. And symptoms can actually be lessened in frequency with exercise, with a good lifestyle. No? Pero sa COPD, once it has set in, the normal function of your lungs and your blood vessels cannot be brought back to 100%. If you will look at this graph right here sa baba, this is a graph representing yung sa baba, no? Your age in years. Say for example, nag-start ka mag-smoke ng 25 years old. No? Pero alam natin, a lot of adults right now have started smoking probably before 20 pa. No? So, yung estimate, 25 years old. And then, si FEV, yung sa y-axis natin, no? Ng graph natin, FEV is a measure of lung function, kung gaano ka daming hangin pa yung kaya niyang inhale and exhale. No? This is one way that we use, this is one value we use or we measure in spirometry para malaman kung yung tao ba nakakahinga ng maayos. So, makikita nyo, if a smoker who started at 25 years old continues to smoke and is only able to stop at an age of 45 years old, yung lung function niya, relatively, hindi pa pupunta sa point na disabled siya. Pag sinabing disability, because of the effects of the smoke, na hirap kang huminga to the point na pupunta ka lang ng CR, hihingalin ka. Hindi ka makatulog kasi gigising-gising ka na ganun ka. Or, hindi ka makahiga at all. No? So, buhay ka, pero
yung mga basic functions na ginagawa mo noon na hindi mo man lang iniisip, ngayon, hirap na hirap ka na. And actually, if you think about it, is it really a better life than death, no? Kung hindi ka mga maka-CR, na hinihingal ka, onting lakad lang, masaya ba mabuhay nun? Siyempre hindi. So, 25 to 45, that's 20 years of smoking. No? Pero they'll live, no? They're probably going to die later pa, beyond 75. Kaya lang, at the point na nandito na sila sa age 75, hirap na yan sila. Ill na sila. As compared to people who never smoke, no? Tawag dito? People who never smoke, no? Bumababa yung lung function nila, pero not to the point of disability. This is just an effect of aging. Kasi syempre, kukunat na yung vessels, kukunat ng onti yung bronchioles, may mamamatay na alveoli. It's part of the natural process. Pero at this point, at 75, you're not breathing with difficulty. Okay, now let's go further. Paano if the smoker, is the bottom line right here, continues to smoke after the age of 50, tumigil lang siya nung 65 na siya kasi sabi niya, hirap na ako huminga lagi, titigil ko na to Yossi. Pero may sakit na siya at matagal na yung sakit, no? Kung tumigil siya dyan, hindi siya aabot ng 80. Most likely yung mga ganitong pasyente, actually, pag umabot kayo sa age na to, nakagamot na kayo, definitely. Mga 3 inhaler, tapos mga ilang tableta, apart from disease in the lungs, yung COPD natin, may iba ka pang sakit, definitely. So, not a good way to live, plus, you're going to die soon, sooner than you expect, di ba? So, for those of you who are still smoking, this graph shows to you that there's hope, di ba? Stopping before the age of 45 if you already smoke at age 20 or earlier, will have a significant difference in the quality of life pagtanda nyo. Gusto nyo ba pagtanda nyo, naka-wheelchair kayo lagi, naka-oxygen kayo, may mask sa bibig nyo, kasi pag tinanggal yon, hirapan ka huminga, diba? So, pag-isipan mo mabuti. Okay. So, poor VQ mismatch there. Other causes, no? So, ito, daanan nyo lang actually. Hindi nyo kailangan pahirapan masyado yung sarili nyo. If there's collapse of the alveoli, lalo na pag nalunod, mga nalulunod, papasok yung tubig sa loob ng baga, pwedeng yung ibang alveoli doon, hindi na siya lolobo, magko-collapse siya because of surface tension created by water. Sa mga bata na pinanganak na premature, wala pang surfactant sa baga. Yon, no? Yung surfactant galing kay type 2 pneumocyte to make sure that if water comes in, hindi siya magko-collapse. Sa baby na premature, ko-collapse kagad yon. So, pag sarado ang alveolus, wala kang ventilation, poor VQ mismatch, so mangyayari, ang VQ ratio mo will be very small. Kasi V ang maliliit. In lung infection, sikat ngayon. So now we're living at the time of COVID-19 or SARS-CoV-2. Let's go to that slide. Okay, sige. Si COVID-19 is actually similar to other pneumonias, no? In the sense na kung ano yung effect niya sa baga. Baga lang, ha? So, yung baga natin, pag pinasukan niya ng virus or bacteria, since foreign pathogen yun, hindi yun kalaban yun, your reaction of your immune system is to, una, constriction reflex, isara yung bronchiole, maglabas ng mas maraming mucus para madaling tumira doon yung immune cells, tsaka matrap yung bacteria or virus. And, yun, mamamaga essentially yung baga mo. Kaya lang, the problem with the new SARS-CoV-2 virus, this process happens exponentially and faster. So, mas maga, mas mabilis, mas maraming tubig sa baga, no? At dahil maga yung daanan at may tubig na napupuno yung mucus doon sa alveoli, ventilation is significantly decreased. Hindi papasok yung hangin. Kaya kailangan nakamask sila para itulak pa further yung hangin para lang makakuha ng kahit konti. No? Another problem with COVID-19 is yung complication, apart from yung sinabi ko na exponential na constriction tsaka yung mucus, that can still progress pa to affect Kasi parang pwedeng yung mga ibang pneumonia namin kasi, pwedeng one area lang ng baga. So, okay pa yung iba. So, hindi sila namamatay kagad. Or sa baba lang, no? Medyo mas mabagal, no? Problema kay COVID-19, it happens faster, it progresses faster, and mabilis na maapektuhan yung buong baga, no? So, significantly, mababawasan ng ventilation. Magsasuffer yung katawan kasi wala nang oxygen. Tapos, asthma, nabanggit ko na. So, ventilatory issue din siya. Okay? Pero walang lung tissue damage. So, nare-reverse. Yung ibang mga nabanggit ko na infections, tsaka yung COPD, it causes damage to the lungs, no? So, nangangapal. Si bronchial asthma, madaling ibalik to 100%. And then, yung nakaka-affect sa perfusion is your mga atherosclerosis. So, sakit na naman ng mga matatanda. Pero lately, we've been having adults na may atherosclerosis as early as 30 plus. Oh, yan yung sakit na merong nagiging namumuong fat plaque, no? Sa daanan ng dugo, lalo na yung maliliit na daanan ng dugo. So, pag may nakaharang, pangit ang agos, mas mabagal, tsaka onti ang umaagos. So, ang affected is perfusion. No? Yung ventilation mo pwedeng okay, pero hindi pa rin enough yung flow ng blood to get as much oxygen as possible. Sa hypertension, pag nangyayari kasi sa hypertension, dahil sa pagtanda or from other factors, nagiging makunat at mas maliit yung kalibre ng blood vessel. So, kada tulak ng dugo, hindi siya elastic enough to expand, to accommodate more. No? So, less ang perfusion sa kanila. Okay. Sige. So, actually, dyan na nagtatapos yung discussion natin sa respiratory system. Medyo may hirap yung topics dito sa second video. So, please try to study from other sources. Okay. Sige.